Welcome to Understand the Math. We're going to look at some examples where we're going to use limit laws to evaluate some limits. We're going to start with some algebraic examples. We're given that the limit of g of x as x approaches some number a is equal to 0. The limit of h of x as x approaches a is equal to 9. And then the limit of f of x as x approaches a is equal to minus 5. And we're asked to evaluate the following limits. Let's look at our first one. We want to find the limit of f of x plus h of x as x approaches a, and we're going to use the sum law to evaluate this. The sum law tells us that we can just pull the limit inside and apply it to each function separately. So this is equal to the limit as x approaches a of f of x, which is minus 5, plus the limit as x approaches a of h of x, which is 9, and we get a value of 4. Let's look at example 2. We're going to use the power law for this example. We're going to evaluate the limit of f of x squared as x approaches a. This just means we can pull the limit inside, and we're going to take the limit of f of x, which is minus 5, and then we're going to square that, and we end up with 25. Let's go to example 3. We're going to use the root law to evaluate this one. We're going to pull the limit inside the radical. So we have the limit as x approaches a of h of x, which is 9, and we're going to take the cube root of that. The best way to write this answer is just to write it as 9 to the 1/3. Or you could also just leave it as the cube root of 9. Let's go to number 4. For this limit, we're going to use the product law. So we're going to take the limit of h of x as x approaches a, which is 9, and multiply it by the limit of f of x as x approaches a, which is minus 5, and we get an answer of minus 45. I hope that you're getting the hang of this. Let's look at number 5. For this one, we are going to use the quotient law, and we're going to have the limit of g of x as x approaches a in the numerator, and that's going to be 0. And then in the denominator, we have the limit of f of x, and that's minus 5, so we get an answer of 0. Let's now look at the last one. For this one, we are also going to use the quotient law, and it's just like number 5, except we're just going to switch the numerator and the denominator. So this one is minus 5 over 0. When we have division by 0, we have an answer that does not exist. So we're going to write our limit as DNE. That's just the abbreviation that you use for does not exist. Let's now look at some graphical examples. I think these are a little bit harder than the algebraic ones. We are given the graphs of f of x and g of x, and we're asked to evaluate the following limits. Let's move this up so we can see our limits. And let's start with number 1. For number 1, we're going to use the sum law. So we're going to take the limit of f of x as x goes to 2, and we're going to add to that the limit of g of x as x goes to 2. Now we have to look up at our graph. We're going to be focusing on 2 in both of our graphs. For our first limit, we're going to look at the limit as x approaches 2 from the left and from the right. So it's going to be approaching this number, and that's going to equal 2. So this is going to be 2. Now let's do the same thing for our graph on the right. We are going to be approaching 2 from the left and from the right. And you can see that we get to the value of 0. So we're going to add 0 to this, and then our answer is equal to 2. Let's now look at our second one. Just to save time, I'm going to not write down that intermediate step that we wrote down for the first one. We can just do that in our head. On the graph on the left, we are going to be looking at the limit of f of x as x approaches 1 from the left and from the right. And we can see that that goes to a value of 1. So let's write down 1. Now let's look at the graph on the right. We are going to be focusing on 1. So we're going to look at what happens as we approach 1 from the left and from the right. And you can see that it's not the same value. When we approach from the left, we get 2. And when we approach from the right, we get 1. Those are not equal. So we have to write down that this limit does not exist. And then 1 plus d and e is also equal to d and e. So that limit does not exist. Let's look at number 3. We are going to be focusing for this one on 0. Let's put a pink dot at 0 so we can know where we're looking. For the function on the left, we are going to be approaching 0 from the left and the right, and that's going to equal 0. And then for g of x, we're also going to be approaching from the left and the right. Here's the left, there's the right, and we're going to get 1. So we have 0 times 1, which is 0. So our limit is equal to 0. Let's look at our last one. For this one, we are going to be looking at the point x is equal to -1. So let's highlight that. For f of x, we are going to be approaching from the left and from the right, and we get a value of -1. So this is -1, and we're going to divide that by our g of x limit. Again, we're focusing on -1. We're going to come from the left and the right up here at g of x, and we get a value of 0. So we have -1 over 0. Whenever we divide by 0, we end up with a limit that does not exist. So we're going to write down d and e for our answer.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.